All right, everyone. We are here today to talk about infrastructure as a code with the help with emerging technologies. Before we start, I want to say thank you so much for Quest Oracle community for organizing this event, the InSync 2021. It's an honor to be presenting here today. I have been working and presenting in some of the Quest events in the past, especially when done in Las Vegas, and missing a little bit of the face-to-face, see the people, meet. Hopefully this pandemic situation improve very soon, and we can start having some face-to-face events once again. And also with this session today, I will remind you guys, please to do field evaluation afterwards. The session ID for this session is 101010. Very simple and nice. That means
Good one.
101010, very nice and easy to remember. And I will be here today talking with a good friend, and I'm honored to have him here presenting with me today, Avi Miller. They will be also introducing himself in just a moment. A little bit about myself. My name is Francisco Munoz Alvarez. I'm the founder and CEO of CloudDB. I have been presenting in a few conferences around the world and involved a lot with Oracle communities. I am an Oracle Ace since the year 2008, Oracle Ace Director since the year 2009, Oracle Ace Director of the Year by Oracle Magazine in Oracle Excellence Awards in 2010, and founded and was the president for many years, not anymore, but for LLC, the Umbrella User Group for Latin America. Now I'm the founder and president of the APAC Umbrella User Group, APAC UC. Also the president of the Chilean Oracle User Group, New Zealand Oracle User Group, Independent Australia Oracle User Group, and Singapore Oracle User Group. That you can see I still a little bit involved with Oracle community around the world. And I have had the privilege to speak over 470 sessions over 48 countries around the world in the past 10 years. And that's, I think so, is already a lot about me. Let's talk now a little bit about Avi. Hi, Avi.
Hey, Francisco. I don't know how I'm supposed to follow that. Like, where do you find the time, honestly? Hi, folks. My name's Avi Miller. I am one of the senior solution architects for Oracle Cloud. But this is a new gig for me. I've only been with Oracle Cloud for the last month and a half. For those folks who've been around the InSync and OzOrg and Oracle open world sort of events, I've been an Oracle, I was an Oracle Linux product manager for close to a decade. So I've been in Oracle for about all up 13 odd years now, 14 years, all in open source, all in sort of developer focused, open source focused environments. Today I'm doing the fun bits because I'm doing the demo. I have no slides. So what I'm going to do, there's a great slide for this. I added a slide. So Francisco, before Francisco starts talking, because those of you who've heard Francisco know he can talk, what I'm going to do is actually start a couple of demos because they take a while and I want to start them up before we get too far. So what we're going to do is go over to this screen and I'm just going to type Vagrant up. So I'm going to time how long this takes for us. That's going to go and start. The next thing I'm going to do over here on this web page is I'm going to say apply, and it's going to go and start running a job for me. And you'll see it's now running, and that's it. I've just started 2 demos going. I'm going to let Francisco talk now, and we'll come back to them in a little bit. Over to you, Francisco.
Thank you so much, Avi. Just start taking again the control. 1 second. There we go. Thank you, Avi. That's the thing. You could say how you're going to compete with that, but how I'm going to compete with this? You will see. I am on charge of all the boring part about all the theory, concepts, and all that, and Avi will be on charge of the fun and amazing part of the demos. That's good. That's a good teamwork. But I will try to keep it up. But I'm sure the Avi will be all good stuff to show everyone. This is a little bit about what we'll be talking today. We'll be talking about introduction about what's infrastructure as a code, what's the benefits, the problems, how it works, what's configuration orchestration versus configuration management tools, some misconceptions the people have with regards to that, a little bit of examples about tools available. Then AV will be taking over and show the demos for the things they just triggered a few moments ago about emergent technologies a little bit more. If we have time, we will be talking about, have a Q&A in the end, but I suspected we will have not enough time. And if that's the case, we will share with you guys once again my email information, AV's email information, and you can contact us offline, and we'll be more than happy to help and assist. Okay, let's talk a little bit about, sorry, just change it right here. And I always tell everyone when I talk in conferences around the world, especially with the Oracle communities, that knowledge is only valuable if shared. That means if you know something about a topic, you learn some good things about implementation you're doing or anything you have experience in your workspace, I will recommend you to participate in the Oracle user group communities events, create a presentation, show and share what you learn with the community. And you can do that in these events like this. You can do that on meetups. You can do in your blog. You can do writing a white paper. There's many different ways you can help to share the knowledge with the community. Because today I can help someone in one topic, tomorrow somebody else can help me in something I need. And that's basically a two ways road that each person help each other and make your life a lot easier if we share that knowledge. But saying that, let's talk a little bit about introduction to infrastructure as a code. If you take a look in the PPT, the introduction to trends like cloud computing have revolutionized the way companies design, develop, and maintain their IT infrastructure within the organization. One of the critical components as a result of this trend is called infrastructure as a code. I know, a lot of people will come back and tell me, Francisco, so many acronyms to remember now with the introduction of cloud. I need to remember about IaaS, PaaS, SaaS, DevOps, and now you want one more for us to remember. That's kind of hard. That means I know now we need to remember that infrastructure as a service is also called AAC. That means, as I mentioned in the PowerPoint, infrastructure as a code, as known as AAC, is an IT practice that codifies and manages the core IT infrastructure as a software. The purpose of infrastructure as a code of IIC is to enable developers or operations teams to automatically manage, monitor, and provision resources rather than manually configure the hardware themselves. As I tell, AAC is also known as an important part of the new normal within IT, if I make that a little bit easier. We have heard a lot about cloud and DevOps in the past few years. For this case, we need to remember that IAC is the engine and is the engine at the heart of DevOps. That's the more important thing you need to know. But I know a lot of people will say, Francisco, this is still too hard. It's too much information. I'm not getting the concept still. I will say, I'll give you an example of something easier, how Wikipedia defines and describes infrastructure as a code. Infrastructure as a code is the process of managing and provisioning computer data centers through machine-readable definition files, rather than physically hardware configuration or interactive configuration tools. Still too confusing. Let's see if that can make things a little bit more easy. Infrastructure as a code means to manage your IT infrastructure using configuration files instead of you doing it manually on a stressful, riskful, and long way. Always you need to think, as much more human interaction we have, more risk is added to the equation too. As the name suggests, AAC is the concept of managing your IT infrastructure by using configuration files and automation instead of manually doing the job yourself, like logging every time into a new machine, configure it from documentation, and what's stressful, riskful, as I mentioned before, and always take a long time to complete. And furthermore, in the process when doing it, many environments on different time frames, you never do the same time. You do one environment one time, and a few days later or weeks later, another one, and so on. Especially when it gets even worse when you're doing that with multiple teams, different people, different teams working together. The end result is not always the same because everyone follow a different standards, not the same kind of standards all the time. And these people always end up adding their personal touch to the installation, the configuration. So making the end result, this make everything harder to manage it and maintain. And that's not good. Note that IAC isn't just automation and should not be considered as automation only, as it extends beyond simple infrastructure automation. AAC requiring applying DevOps practices to automation scripts and ensuring they are free of any error. That's key. And can be easily redeployed on multiple servers, and it could be rolled back in case of any problem or issue. To achieve this goal, some tools like Ansible, Puppet could be used by anyone that have a basic knowledge of modern coding techniques and infrastructure. Furthermore, once again, this means that the core best practices of DevOps, like version control, virtualization tests, and continuous monitoring, as per example, are applied towards the underlying code that governs the creation and management of your infrastructure, treating your infrastructure now as any code will be. That's the key of this concept and what we are talking today. We can use the AAC to manage a structure via source control, thus providing a detailed audit trail of the changes, apply testing to infrastructure in the form of unit testing, functional testing, and integration testing. We also can avoid writing documentation since the code itself will document the state of the machine. This is particularly powerful because it means for the first time ever that infrastructure documentation will be always up to date. You don't need to document everything. It's only one code documented and that's it. It also enables collaboration around infrastructure configuration and provisioning, most notably between dev and ops. That's why we always call DevOps. At the end, IAC would help us to solve inconsistency, reduce risk, scalability and availability, and reduce cost. That's key for any business today. This is some examples from some of the benefits that we have when using infrastructure as a code for devs and ops. This is for 46 when consulting on behalf of Microsoft back in 2015 and not made much change on this kind of benefits that affect infrastructure as a code from that time until today. All right, just to basically resume what we saw before, some of the key benefits when we start using infrastructure as a code, IAC, is we have speed and security, minimizing shadow IT, consistency, because now we do implementing standardization across the implementation and changes, accountability and safer change handling, good for compliance, especially PCA and many others that we use. Other benefit is efficiency during the complete software development cycle, as we have satisfying customers, can be internal or external customers. And what's key, especially every CFO I know loves this part, help to lower costs by reducing operation and capital expenditures. All right, but how it works is not easy to tell up. Just the concept itself is hard to people to understand. AAC tools can vary as far as the specifics of how they work, but we can generically divide them into two main types. The ones that follow imperative approach and the one that follows the declarative approach. The imperative approach gives orders. It defines a sequence of commands of instructions so the infrastructure can reach the final result easily. A declarative approach, on the other side, declares the desired outcome instead of explicitly outlining the sequence of steps that we need to give to the infrastructure to reach the final result we're trying to achieve. The declarative approach shows what the final result looks like. That's why if you think the categories above I was just talking about have something to do with programming language paradigms, you are spot on. Just to review that, imperative focuses on how and declarative focus on what. In a software engineering context, declarative programming means writing code to describe what the program should do as opposed to how they should do it. As an example of declarative tools, we have Puppet. Well, Puppet is designed simple to look for problems in your code, then fix it by bringing it into the correct state. Puppet doesn't run scripts or execute any code on your infrastructure. It doesn't know how to do that. Rather, it builds a graph of what the infrastructure code base is supposed to look like, then recreates a model of what's desired and the state. Types of automation too, we have two different types of automations that we use with AOC and with DevOps too. They are direct of indirect. Direct automation routines, which are strictly meant to automate infrastructure, are typically written in descriptive scripting language, DSL. Indirect, in the other side, routines are typically written in a language of the application itself. Such indirect routines will align infrastructure to the business logic in real time. Apologies. All right, let's talk about very shortly about some best practices for AAC. One recommendation always is exercise caution when extending AAC to novices, to people with no experience. Why? By design, AAC makes deploying and reconfiguration of servers environments very painless and simple, but that's a double-edged sword. While novices can spin up 100 instances in just a few minutes, they can also do an incredible amount of damage and screw up very easily in a very short amount of time. That's why be careful, be cautious with that. Second, stricter the better. More strictly you define everything in your environment, the fewer problems you will encounter. Specify the environment as strictly as possible, leaving little to change. Be as specific as possible about the infrastructure requirements, including network bandwidth and storage and I/O operations per second. If possible, do that. It is often overlooked, these kind of things. IOC tools are evolving at different rates. One of the things to keep in mind is that platforms like Oracle Cloud, AWS, Azure, and so on are evolving very, very quickly with new features and services showing up all the time. If you take one example for Oracle Cloud and you connect to the Oracle Cloud OCI now, keep a month without connect and you connect again, you will see a lot of things changes because it's a lot of changing happenings, it's a lot of implementations happening all the time because all the clouds are evolving. Third parties very scarcely keeps up to the velocity of the changes like in the cloud. In other words, a third-party tool may often find itself incompatible or behind the times when popular IAC platforms are updated. So if you're trying to stay at the cutting edge of these platforms, accept vendor lock-in or use the open source libraries and contribute your support for the new features back to the community. Finally, containers point the way forward. As noted earlier, AAC is still evolving, and we are in the further evolution as containerization and AAC worlds collide. The question in the future isn't going to be how to manage 100 clones of a single machine, but rather how to manage 100 machines that may have a variety of different configurations. That's why everybody is using containers today, and containers are here to stay. Let's talk a little bit about configuration orchestration versus configuration management tools. I already talked a little bit too much, and that's why I will try to speed up a little bit to let Avi have enough time to the fun part and stop with the boring part very fast. Apologies for that. Configuration orchestration is the automated configuration management and coordination of computer systems, applications, and services. Orchestrations helps IT to move easily, manage complex tasks and workflows. IT teams must manage many servers and applications, but doing so manually isn't a scalable strategy. When you read that, the easy part to you to understand what configuration orchestration is basically the concept behind AAC. In the other side, we have the configuration management tools. Configuration management tools make changes in deployment faster, remove the potential for human error, while making system management predictable and scalable. They also help you to keep track on the state of your resources and keep you from repeating tasks like installing the same package twice or more. In other words, as we spoke just right now, that configuration orchestration is more the concept. The configuration management tools of AOC is basically the how to make the things happen, is the real things that make the things happen in the background. Configuration management tools are the tools that makes everything happen. AEC tools automate tasks in different categories for different phases. The three main task categories that we work with are infrastructure provisioning, configuration of provisioned infrastructure, deployment of application, distinction of phase, and we also work with two different phases, a part of the tasks. They are the initial setup phase and the maintenance phase. This is one example with some of the most common tools that we work today as Ansible, Puppet, Chef, and Terraform. You can see which ones working from the initial infrastructure setup, which ones is used more to manage infrastructure, initial application setup, and manage the application itself. Make it easy with one example. On the cutting edge of infrastructure are containers that I just mentioned before. As per example, Docker, Kubernetes containers. Using Docker as per example, Docker's basic tooling or tools that we have available arguably obviates the need for configuration management tools. The configuration management problem of yesterday roughly translates to a simple Docker file today. Are short that as we know, a Docker file is a short shell script. The complexity of the problem is moving from the state of a single machine to the state of multiple heterogeneous services and the relationships between them. This is commonly called orchestration. In other words, how do we define a distributed application or set of services spanning through multiple machines, their relationships, and desired state of code? The solution basically lies in the Docker Compose tools. This tool describes the runtime state of each services and its relationships between them via simple but powerful data format that we know as YAML. Like a Chef cookbook or a Puppet manifest, this YAML file can be managed via source control very easily with the inherent advantage described above. Docker Compose, however, assumes all containers are on a single machine today. This is a simple example to understand how everything works. We have the developers, they write the code, the infrastructure as a code that we needed, that's managed through a version control system. Then we can push and pull that to our cloud computing and using automation APIs or servers. And then we can manage that deploying everything we needed as infrastructures in the cloud or on premises. When we talk about infrastructure as a code tools, we have many tools available in the market, and every week we have a few more that comes and show up. This market is very hot and is evolving a lot. This is just as a few examples, like you have Puppet, Chef, Salt, Microsoft Azure Automation, so many things that I will recommend you to just take a look and check what's going on. And saying that, oops, I just passed right here. I will leave now, give it back the control to Avi. And Avi, let's go see what's going on with that demos.
Thank you very much, Francisco. Exactly what we should do is go and see what's happening. So what we've got, I'm going to go and look over here. That's still carrying on going. So what I want to introduce you to, what I'm going to talk about today are sort of the baby, the big brother, and the granddaddy of infrastructure as code tools. And we start sort of the user-specific, the developer-oriented infrastructure as code, which is Vagrant. I'm going to pick on HashiCorp a lot. HashiCorp are probably the infrastructure as code company. Most, if not all of their products are pretty much infrastructure as code oriented. Vagrant and Oracle and Vagrant have a long history. Vagrant initially was used to automate VirtualBox, our desktop virtualization product, and it still does automate VirtualBox really well. It now can automate a whole bunch of developer-related virtualization tools, so VirtualBox, VMware, libvirt, those sorts of things. What makes Vagrant really nice in the DevOps space is it makes your development environments repeatable. So Francisco was talking about imperative and declarative infrastructure as code. If you think about imperative infrastructure as code, things like a Docker file, for example, is imperative. The Docker file tells Docker or the build engine what to do on each step. It doesn't actually define a final state that is up to whatever the step does. With something like Vagrant, it actually is imperative, but it looks like it's declarative. It's one of these really confusing ones. And you'll find that nowadays, most tools are a bit of both. Ansible and Puppet in particular are majority declarative, but they allow you to do some imperative work. Vagrant is mostly imperative, but it kind of has this wrapper of declarative configuration. So what am I talking about? Let's take a look at Oracle's Vagrant Projects GitHub repo. Now, we've been doing this for a while. It's one of the ways that we make Oracle developers' lives easier, is that we've provided a whole bunch of Vagrant projects for you to get up and running with some of the more popular tools, including things like Oracle Database, Standalone, and Oracle RAC. For those of you who've built a RAC instance in the last decade, one of the first things I did when I joined Oracle is learn how to install RAC. And it used to take, I think, when I started with 10G, it would take about a week. I got that down to a day. With automation now, it takes about 20 minutes, 25 minutes, depending on how fast your machine is. The one I picked was, in fact, Apex today. I've been playing a lot with Apex. And you'll see, this is my terminal. I typed the command time Vagrant up. It took 23 minutes and 25 seconds in total. And what that did in 23 minutes and 25 seconds, it created a virtual machine. It installed Oracle Database XE18.4. It installed Apex, it installed ORDS, and it created all of that on an instance that I can get to on my machine. There we go. And it did connect. There's my application express. I need to get my password. So we go internal, admin password, and where it goes. No, don't say. There we go. There we go. What's really nice is I've created. I did nothing. It's really nice for me. Again, the only command that I typed to get all of this was Vagrant up. let's take a look at how that works, because there is actually some method to the magic behind it. This is a Vagrant file. It is Ruby. So those of you who understand or read and write Ruby, this is a weird version of Ruby. It's a Ruby DSL, or domain-specific language. It is Ruby. It uses all the same syntax as Ruby, but it's specific to Vagrant. Vagrant's actually written in Ruby, which is why it's DSLs in Ruby. What it does is basically say we are using Vagrant File API version 2. We want to use Oracle Linux 7 as our base box, and Oracle actually publishes Oracle Linux 7, 8, 6, 7, and 8 boxes, but this is going live on April the 1st. Those of you folks, you should know that Oracle Linux 6 reached the end of production life yesterday. So it goes into extended support today on the 1st of April. We do 3 years of extended support. You need to pay for it. If you want security updates for Oracle Linux 6, you should be on Oracle Linux 7 already. I recommend Oracle Linux 8. This one happens to use 7. But we'll skip a few of the sort of obscure configuration. You can get into some really good details, but I wanted to just focus on the basic configuration. We essentially tell Vagrant, I want a VM box. I want it named after Oracle Linux 7. That's where I got my box from. I want it to have 2 gigabytes of memory for both VirtualBox and libvirt. One of the things that we do, and what our Vagrant team have done, is that they make sure this works both on a VirtualBox instance if you're running on Windows or Mac OS. It also works on libvirt. So if you're running on Oracle Linux 7 or 8, if that's your desktop or you're using Oracle Linux KVM, you can actually run these directly on a KVM host using libvirt. We have some proxy stuff. We're going to forward some IP addresses. We're going to change a host name. And then when we get to provisioning, we're just going to run some scripts. I mean, this is, it is pretty straightforward. It's basically an imperative system that says, I want this VM created, I want it based on this operating system, and then I'm just going to run some scripts. And the scripts are, like you'd expect, pretty straightforward. They do yum updates, they configure yum, they set some environment variables. We have created our pre-install RPM for years that just basically configures a machine for database. So it's great. And it goes through all of those things. You can configure this. You can customize it. You can change the database settings. You can change the Apex settings if you want to. And then all you need to do to get a repeatable, a replaceable, reinstallable, crash and burnable Apex instance is type Vagrant up. And in 23 minutes and 25 seconds, you get a brand new, complete running Vagrant system. The value in this for for developer teams is significant. It means that if you define your development environments using Vagrant files, you know that when a developer types Vagrant up, regardless of whether they're running Windows or Mac OS or Solaris or Linux or something else, BIOS or Amigos or whatever, they wrote their own OS and they're running that. As long as it runs Vagrant, the developer environment that they work on is the one that you've defined for your app. You know that the virtual machine is running the packages and the libraries and the OS and everything else that is going to be on production. So this is, sort of a developer environment as a service, if you like, and it's portable because Vagrant runs and interacts with VirtualBox on any of VirtualBox's supported platforms and others. It goes with the developer based on their platform. It doesn't enforce one. You don't have to enforce an operating system for your team. They can use the one that they're familiar with, and you still get the benefit of consistency. So that's the baby version. I'm going to just highlight very quickly that we have a whole bunch of Vagrant projects, including things like Oracle Apex, DataGuard, the database, Golden Gate, Linux, Rack, OLCNE, our on-premise Kubernetes distribution, as well as things like the Docker engine on OL7 and container tools on OL8. And we take code contributions from developers. It's all on GitHub. Go and check it out. Contributions welcome. If you think there's a product or a project or an Oracle thing that is too difficult to install or needs automation for repeatability, we'll take your contributions. So that's how you that's the dev part of DevOps. In the middle, and I'm not actually going to talk about them for much, but in the middle of the configuration management tools, there are things like Ansible and Puppet and Salt and Chef. Those are the tools that essentially ensure that your environment remains consistent through its life cycle. So if you consider Vagrant is building development environments, then you have something, you need something that builds production environments, and you need something that maintains them. So the big brother of Vagrant is Terraform. So Terraform, also a HashiCorp product. Terraform is the granddaddy, if you like, of infrastructure as code. It's probably where we first started using the phrase infrastructure as code. It builds infrastructure as its main task, and it builds infrastructure anywhere. That's kind of one of the things that it is really powerful about it. You can create Terraform plans that target Oracle Cloud infrastructure, that target your on-premise infrastructure, whether that's based on KVM or VMware or bare metal instances. You can provision bare metal instances with Terraform. You can provision cloud instances. You can provision VMs. You can provision containers. You can do all of those things in using configuration tools that are all text. They're all able to be stored in Git. You can publish them. You can manipulate them. We have a whole bunch of quick starts for Oracle Cloud Infrastructure. These are tools that are designed to get you up and running very quickly with a particular solution, whether that's, I'm going to use our cloud native demonstration solution in this demo, but we've got things like Fortinet for the firewalls. We've got OKE with service brokers. We've got Apex. We've got Jenkins. We've got Bastion hosts, and a whole bunch of, here's a quick way of getting deploying a particular service. And you'll notice there's a theme in these descriptions. They're all Terraform modules. Terraform modules to deploy OCI Postgres, to deploy Gluster, CockroachDB, Azure Interconnects. They're all using Terraform. And the reason we do that is because Terraform allows us to take, if I'll take a look at these Terraform scripts for us, it basically allows us to define things as fairly easy, fairly readable code. So what we're going to do is we define a whole bunch of, in this case, it's Helm charts for Kubernetes, because most of the MooShop is a cloud native thing and they all run as Kubernetes pods. I have really easy things to define. Here's my variables. It's always called variables.tf. I need to provide the standard OCI stuff like tenancy and compartment and region and fingerprints and all those sort of things that the OCI CLI would use, that you would use if you were interacting with OCI. And interestingly enough, if we're going down the imperative versus declarative route again, the CLI tools are imperative. If you're using OCI CLI, you're imperatively telling it to do something, but the endpoint isn't defined by the command. It's whatever happens through the action that you run. What we've taken this one step further, because we thought, you know what, having Terraform scripts is nice, but wouldn't it be better if there was a button? And so we created the button. It's called Deploy to Oracle Cloud. You'll see it on a bunch of our quick starts here on GitHub. You'll also see it in our learning library, in our live labs, those sorts of things. You'll see a Deploy to Oracle Cloud. If you click the button, it takes, oh, I logged out. There we go. Let's log back into my Oracle Cloud account. If you click the button, log you in. Let's log myself into my cloud account. Yes, no, that's it. Thank you. Come on, let me click the button again now that I'm logged in. Go back, where did I go? I actually logged out of my cloud account because it's easier to log in as part of the button. So let's push the button a bit again. I'm doing the right thing and preparing everything in advance, and our security logs me out. So here's what happens. We've got a tool in OCI called Oracle Resource Manager. Oracle Resource Manager is Terraform as a service. So it runs Terraform for you on your behalf inside Oracle Cloud. So you can see here's, it's going to create a stack. I've reviewed our terms of use. I'm going to give the stack a name like MooShop. I'm going to give it some description if I want to create it in the compartment. These are standard OCI settings. The nice thing is all those variables that we saw in the text file, Resource Manager is going to fill in for me. It's going to create a new cluster. It's going to ask me which kind of node shapes I want to use. Do I want to use Kubernetes dashboard? Do I want advanced options? I'm actually going to cancel this one because if you remember way back then, I clicked apply on a web page, and what I was doing is the MooShop. I had done that import of the Terraform. I clicked the button, it is imported the Terraform. If you come into the MooShop, I hit Terraform action apply, which is essentially just go build it. And you can see it took from 0330 to 0352, so it's 22.25 minutes. And what it built is quite remarkable. So it's created an autonomous database. It's created a container engine cluster, so an OKE cluster of 3 worker nodes. It's created the VCN, it's installed Helm, it's created all of our Kubernetes secrets and Kubernetes configurations. It created the database wallet. It created all of the private keys for the MooShop components. It's deployed MooShop, the actual application, into OKE. It's created object storage. It's created load balancers. It's created ingress. It's created route tables, security lists, node pools, the whole thing. It tells you things like in our outputs what the autonomous database password is. It shows you what your external IP is, where Grafana is for monitoring, and where the MooShop is. So if we take a look at this, there's the MooShop URL. I didn't enable DNS for this, but I'll just go and visit the MooShop. And MooShop is where you could buy cat things. And you can get the source code for this online. You can go and buy stuff. There's my instant Moo Broom kit. And it is a fully working cloud native application. And it highlights a whole bunch of polyglot instances. If you want to dig deep into it, go for it. It has things like GraalVM and Node.js and Java and service meshes using Istio and AB stuff. And it's fantastic. It's a really great example of everything you can do with Cloud Native and all the OCI services behind it. I'm just using it to show off Resource Manager, because if we go to the stack details, we can go to the application information, and there's the MooShop. Again, tells me what I deployed using that button. It's all the infrastructure as code. It's all in Git. So if we go back to, if you play with our GitHub repos, you can actually see all the source code. And what it's done is all of the integration stuff for you. I'll go to our Grafana login as well to show you that. There's the Grafana admin password. Just I'm showing off because I really like this demo, and it's the MooShop is built by my team, or the team that I'm in, I should say. So we're quite proud of it. So we think it's quite nifty. So if we go home, let's go to our dashboards. Come on, I want to see my dashboards. There we go. Come on. Manage. There we go. So it's automatically created things like Kubernetes clusters, dashboards. You can monitor how your MooShop is doing. The end result of this is that you can create, this is a great demo, but it means that if you develop your applications, you start with something in Vagrant Box, using Vagrant VirtualBox, you define development environments. They are always the same. We use the term idempotent. It's a great word. Win trivia matches with idempotent. It means that the same result will happen every time you run the process. You want your infrastructure as code to be idempotent. If you run this thing over and over again, you should have the same result every time. You start with a known good Vagrant environment for your developers. You build your application with IAC in mind. So you're developing your Terraform scripts as you go, which means that when you come to any cloud vendor, and I'm biased, I think you should use Oracle Cloud, but you can use others. Our competitors also have similar tools. The strength is that every time you hit Terraform apply or Ansible go or Puppet apply and all those sorts of things, you get the same result. You are able to build the instance of your application every time. Nowadays, having one instance in one location is not enough. You need multiple instances, you need multi-cloud, you need hybrid cloud. This allows me to, I've targeted, this has been deployed in Ashburn, in the US. I'm actually based in Melbourne. I could go and just go to Melbourne and then do exactly the same thing. I need to go and find my resource, but I could go and deploy a resource manager, create the same stack, click the same button, create a container compartment in Melbourne, deploy exactly the same configuration, and I get the same application. Now I've got it running in 2 availability zones or 2 regions. It eliminates human error. It eliminates configuration drift, and it eliminates all of the little things that make troubleshooting that much more difficult, particularly when the infrastructure is that much more isolated or that much more disconnected from your day-to-day operations. So that's me. That's the demo. It was very brief. Hopefully, it was enough to give you a taste of what is possible with infrastructure as code. I urge you to look into things like all of our APIs and SDKs for Oracle Cloud. So we've got SDKs for Python and Ruby and Java and Go and TypeScript. We have CLIs, but we also have plugins for the other configuration management tools. Yes, we support Vagrant with VirtualBox, Terraform with OCI, but we've got a plugin for Ansible for OCI as well. So you can use Ansible. We've got Chef Knives for Chef for OCI. We've got Puppet plugins for OCI. The other tool that I just want to give a shout out to, because we use it a lot, is Packer. Packer sits somewhere in between Vagrant and Terraform. It allows you to build images. So it's a system that takes a base image and applies your changes and creates a final image for you. And you can then use that to deploy those images on multiple clouds. You know, you can use the same thing to deploy to OCI and Azure and AWS. And again, idempotency, repeatability, lack of human error, all good. That's me. Hand it back over to Francisco.
That's cool, Avi. Excellent presentation, excellent demos like always. But how cool is all this about infrastructure as a code is that, look, remember in the old times, not that old, that when we receive the new requirement of a new application that will be developed and implemented on environment, when we need to requisite a new server for development, a new server for QA, order for a production. Then we get a team. I start setting up the things for development, get the machine when they arrive after a few weeks, connect to the storage, set up the OS, start ensuring that I have all the packages that I needed, start installing the application, configure as per the best practice in the manual they will receive. On parallel, I have another team member doing the same, and so on. In the end, we end up with developing with one version, one release of the OS, another machine with a different one, another one with a different one, different packs installed of each one of them, different the configuration with different flavors depending to the touches of each one of the team members was doing. And this whole process take weeks to be done, from the server requisition, configuration, and everything that happens. And now with technologies like cloud computing, infrastructure as a code, as you just show yourselves in your demo, in less than 30 minutes, you had a whole environment deploying the cloud and ready to go. How amazing is that? That's very cool. And now I have a good friend that before was working with the Linux team. Now I have someone I can scream for help when my team has issues with this kind of products, and especially with Oracle OCI.
And I shout out, by the way, while you're dobbing me in there, Francisco, for the developers out there, for those folks who are developing with OCI, who are using existing tools, if there are gaps, if there are things that you think could be better, if there's questions that you have, my email address is there. Well, I'm now on the developer adoption and experience team. So I'd like to know from folks what's good, what's bad, what's missing, that kind of stuff as well. So feel free to let me know.
No, that's great. That's good. As we pass a little bit over the time that we have, folks, please, if you have any questions or do you want to talk a little bit more about this, please feel free to contact Avi or myself. Or emails are on the screen at the moment. And again, we would love to know what you're doing with AAC and what things we can learn also from you guys too. And saying that, I would like to finalize this session. Remember, you guys, to please help the Guest Oracle community giving your feedback about the presentation. And if you can go and do the feedback for the session ID 101010 will be deeply appreciated. Thank you so much.
Thank you very much.
Thank you so much, my friend.
Thank you. Have a great day, folks.
Have a good day and be safe. Bye, everyone.